Welcome to our Calculus 1 videos. This video is going to be about evaluating some simple limits using the limit laws. So the first one we're going to take at is the limit as x approaches 8 of x squared minus 64x plus 12 over x minus 8. Now our basic strategy here is going to be, we'll take our number here as x approaches a, so that's going to be 8 for our value of a, and we're going to plug that in and see what we get. So when we plug this in, our numerator is going to be negative 436. That's just do 8 squared minus 64 times 8 plus 12. And our denominator, we're going to notice, is 0. So that 0 in the denominator is going to make this thing undefined. So that really doesn't help us very much. However, we can notice that if we have a number over 0, that usually is going to imply that we have an infinite limit. So we're going to want to see what we can find with this information. So we're going to look at numbers to the left of 8. So something 7, 6, 5, 0, anything like that. So what we're going to look at is the denominator here. So a number to the left of 8, like 7.999 or something very, very close to 8, but to the left, is going to make this denominator negative. Okay, so we have a negative in the denominator. Then we're going to look up here at the numerator. That's also going to be negative if we have numbers very, very, very close to 8. Now you can just spot that that's going to be because the 64 times a number very close to 8 is obviously going to be way bigger than that number squared. So when we subtract them, we're going to get something negative. If that strategy makes you a little bit uncomfortable, you can plug in a couple test numbers very close to 8 in your calculator and see if they're positive or negative. However, you're going to want to make sure that those numbers that you plug in are very close to 8, 7.9999, something like that. So this negative over negative means that our infinite limit is actually going to trend to positive infinity, because a negative divided by a negative is going to be a positive. So when we take these numbers that are very large in the negative direction from the numerator here and divide them by something negative from the denominator, we're going to get a positive infinity. So that's what our left limit is. Then from the right. So from the right of 8, notice that our numerator is still going to be large in the negative direction, right? Because the 64x, again, we're plugging in something very close to 8 times 64, that's very big. And then that number squared, well, that's not going to be quite so big. So when we subtract them, that's going to be negative. Then our x minus 8 now is going to be positive, right? Because we have a number greater than 8 and we're subtracting 8. So we're going to have very large negative numbers in the numerator divided by positive numbers in the denominator. So that's going to trend towards a negative infinity. Now notice that these left and right limits don't exactly exist. This is just their trend, right? So since the left and right trend to different things, our overall two-sided limit won't exist. So two-sided limit, and we usually abbreviate that by DNE. That limit does not exist. So here we have another example of a limit, and this is the limit as h approaches 0. And we have this function that is a function of x and h. We have two variables. Don't let that confuse you. We're going to still use our standard steps to evaluate the limit. First though, I'm going to write this a little bit differently because, like most of us, I do not really like to look at all these fractions. So right now we're just going to write this a little bit in a nicer form, right? So we're just going to write that whole thing multiplied by 1 over h, right? That's the same thing as dividing by h over here. This just looks, in my opinion, a little bit better. Now we're going to take our strategy of let's plug in 0 and see what we get. So plugging in 0, we're going to get 1 over x, right? When 1 over x cubed when h is 0. Then minus this 1 over x cubed. And then that whole thing times a 1 over 0, which actually turns out to be 1 over x cubed minus 1 over x cubed is 0. And we're dividing by 0, so we get 0 over 0. When we have 0 over 0, that usually implies we need to look for something to cancel. Okay, so we're going to try that approach here. So I'm going to take this fraction here, this 1 over x plus h cubed, and then minus 1 over x cubed, and we're just going to find that common denominator and subtract them. So when we do that, we'll get the limit as h approaches 0, and we're going to get our first fraction here, 1 over x plus h cubed, is missing an x cubed. So we're going to multiply it by x cubed, and our common denominator here, x plus h cubed times an x cubed. And then we're going to subtract the second fraction here, which is missing an x plus h cubed. So there we go. And then all of that, of course, is still multiplied by our 1 over h. We don't want to forget about that. So now we're going to take this x plus h cubed in the numerator here, I'm underlining it, and we're going to expand that. So if you remember how to, oops, I forgot my limit sign, h approaches 0. If we remember how to expand that here, we're going to get our x cubed still there, and we will have x cubed plus 3x squared times an h, then plus 3xh squared plus h cubed. Now if you don't remember that little trick, you can just write x plus h times x plus h times x plus h and then do all that distribution, and then we'll carry down the bottom here, so x plus h cubed times x cubed in the numerator, and then we have a 1 over h still left over. So now we're going to notice that this x cubed here actually cancels out with this x cubed here because we have this negative. So now everything that's left in the numerator has an h in it. Okay, so we're going to pull that h out, and we'll get the limit as h approaches 0 of, still have that negative there, h times 3x squared, right, because we had 1h here, plus 3xh, because we had h squared, so we're only taking 1 out, and then we have plus h squared instead of h cubed. And then this whole thing over x plus h, that quantity cubed, times x cubed. And then 1 over h there. So now this 1 over h can cancel out with this h, and the cool thing about that is we're going to get something now that we can apply our direct substitution to. So let's write this out so we can see a little bit clearer what's going on. So we're left over with 3x squared plus 3xh plus h squared. We have that negative still out front, and then our x plus h that whole quantity cubed times x cubed. Now what happens when we plug in 0 for h? Then we are going to get negative 3x squared plus this quantity goes to 0, and this quantity goes to 0 when h goes to 0. So we're going to get 3x squared plus 0. Then in our denominator here, this h goes to 0, so we're just left with an x. So we'll have x cubed times x cubed. So that's actually going to be equal to negative 3x squared, and then over x, well, x cubed times x cubed is x to the 6th. Now we have a 2 and a 6. We can just cancel 2 of those out, so we'll have negative 3 over x to the 4th, and that is our final limit.